Yeah, so you guys have to look at this side. My camera, I cannot connect it to the screen here. You can move it close to it. Okay, sorry, today we start the 15 minutes delay and we're going to add the 15 minutes at the end, okay? Who wants to record it? Alex Chen? Okay, let me ask. Yeah, my computer was broke dead, so I used another computer. That's the reason there was a little bit trouble at the very beginning, okay? Yes, so now let's start, okay? Yes. So we will, today we are going to study some geometry problems. Well, every time we focus on one point, okay? One topic. The first problem I want to begin with is about the special right triangle. The triangles, right triangle with the integer side lengths, okay? So this is the first problem, okay? So we know that in the coordinate system, okay, we have 2 points. One is A with 5 and 2. Another point is and B and 5 and -1. So there's another point, C. The question is how many right triangles you can get. With integer side lengths, okay, can be formed with the vertices A at 5 and 2, B 5 and the -1, and C was called X and Y. So so this is a question, okay? Now there are not many special right triangles there. There are not many special right triangles there, okay? And in order to solve the problem, you look at the distance between A and B, the distance between A and B, okay? A and B, the distance between A and B is going to be 2 minus -1, it's going to be 3. So right triangles, you know that the right triangles with integer length, the only possible one was one side of 3 is a 3 square plus 4 square equals 5 square. So this is really not a geometry problem, just counting problems, okay? Yeah. All right, so in order to make right triangles, the other side must be 3. The AB cannot be the hypotenuse, okay? Can be only the one leg of the right triangle. And the 3 is the smallest integer among all the integers. So it's how many of them? 4.
Can't really see it.
Okay. How many of them? So this is going to be 4. Okay. One triangle is like that. Another right triangle is like that. Okay. And the third right triangle could be this, and the fourth one is like this. Okay. So I'm going to. So you can find the coordinates. Right.
时间不够长。
Okay, so there are 4 right triangles satisfying this conditions. So among all the integer right triangles with the integer length, you 3 probably the smallest number. Okay, 3. You know, all the special right triangles with the integer side lengths. Well, small should be the smallest. 3 is the smallest integer, so that's why you only have these special triangles. And then you look at this picture, there are 4 positions you can have, right? Yeah. Okay. Unfortunately, those 2 things in class here that do not bring the homework. Otherwise, I want to look at the homework problems to discuss it. I don't know why you don't bring the homework.
I forgot mine.
Okay. All right. So I cannot remember all the problems I get from students. They're asking me how to do that, but I cannot recall the details. Okay, I don't have the copy of the homework thing. So our next problem I want to discuss, okay, is as follows: 2 spherical scoops of ice cream with a radius 1.5 inches sit on the top of the cone with base radius 1.5. So here's a picture, okay? Okay, this is a radius, I is going to be 1.5 inches. So 2, yeah. And this going to be have the height h, okay? So the question is, 2 spherical.
Height is 8 or 6?
The height is h. We don't know yet.
Oh, h.
Okay. Okay. They have the same radius. I equals 1.5 inches. Okay. And this is sit on top of a cone. Okay. With the same radius with the base radius I equals 1.5. Okay, so this is a question. My question is, this is the problem. Yeah. The question: if the cone holds exactly the same volumes of both scoops together, what is the value of the h? Okay, so if the volume of the cone equals the total volume of the 2 scoops, what is the value of h? Okay. Now, to solve this problem, you need to know how to find the volume of the ball, how to find the volume of the cone. Okay. So the volume of the ball, okay, the volume of the ball is going to be volume of the ball is going to be 4 pi r cubed divided by 3, right? The volume of the cone is going to be pi r squared multiplied by h divided by 3. Okay, so that's the formulas we should know. Okay, and then using the given information, the volume of the cone is going to be equal to the total volume of 2 scoops, right? Scoops. So the volume of the volume of the scoops, okay, 4 pi r squared, right? R squared is 1.5 cubed divided by 3 and multiplied by 2. This should be equal to 1/3 the volume of the I is 1.5 squared times h. Okay, so this is the given information. the volume screw. Okay, then you solve the linear equation as long as you know these formulas. Okay, then you solve so you cancel it. Okay, and you also cancel pi, right? 4 is there, right? 1.5 cube, 1.5 square. So H is going to be 4 times 2 times 1.5. So the answer is 12. It's integer. Right? Uh-oh. Kevin says 3. It's 12.
Kevin Zane.
Kevin Zane. Okay, Kevin Zane is the only one giving the answer online. Okay. But that's 12 inches. Put it. Okay. All right. So this is it's not a trivial. Sometimes you have to really pay attention to the problem. Okay. So how many of you know how to count the exterior angles, interior angles of a polygon?
180.
Yeah. If for n polygon, okay, n polygon, right? The total, the sum of the interior angles. The interior angle is going to be n minus 2 times 180 degrees, right? And the sum of exterior angle, okay, is always going to be 360 degrees, independent it's independent of the sides, the number of sides. Now, how do you count the interior angle? Yeah. Exterior angle is this one, right? Yeah. This is its exterior angle. But interior angle should be this is the interior angle. Beta is the exterior angle. It's counted like this. You count it clockwise. Okay, extend the one side and then you count it. Okay. Okay. So here's a question.
There's 4.
If a regular 12-gon has exterior angles, right? Exterior angles measuring m's, m degrees, each, and has a total of n diagonals. What is the value of m plus n? Of course, n plus n has no geometric meaning here, but I just want to get the one number. So you needed to find out. You need to find out m and n separately. Okay, 12 polygon, right? It's harder to draw 12 polygon. Okay, so what is the exterior angle of the 12 polygon? Okay, exterior angle is defined like beta, right? But the same also, they're all beta. So how many betas there are? 12 beta. It's going to be, right? 12 beta is going to be 360 degree total. Yeah, the sum of the exterior angles can be the same number. So that's why 12, yeah, 12, this is using exterior using M. That's using M here, not standard. Yeah, I'm not going to use a beta. Okay. Okay. So 12 times m. Okay. 12 times m, 12 m degree. Yeah. So m degree equals divided by 12. So it's going to be 30 degrees. So m is going to be 30. Now, can you figure out n? Can you figure out n? How many diagonals there?
$24.
Hmm?
24.
24 diagonals?
Yep.
So formula for the number of diagonals is going like that, okay? So you have a, suppose you have a, yeah, you from fix a point, how many diagonals you can get? Okay, from fixed point.
We lost.
So that if there are n sides, n points, so n minus 3, okay?
We lost.
Each point, from each point you have n minus 3 diagonals starting from that point, okay? You cannot count those 3 points next to each other, you know, right? Okay, so, but you have n points, it's multiplied by n, okay? This is a, no, this, I'm not,
We lost.
yeah, I'm using K here, okay? K polygon. K polygon. K sides, okay? With K sides. So this is the number of, divided by 2, this is the number of the diagonals. Okay, the number of the
Totally
diagonals.
lost.
You totally lost?
Yeah.
Okay. We have to derive the formula for the number of the diagonals. Okay. That's the formula I gave to you before, but look at the special case. Look at the case when it's a square, right? If it's a square, you only have for each point, you only have one diagonal, right? Okay, from that point, you have one diagonal. Okay, from that point, you see diagonal going like that, right? But then from here, you can go this way. From here, it goes that way. So each point you have a one diagonal, which means 4 minus 3, just only 1. But you have 4 points, so multiply 4. But the diagonal is counted twice. So you have to divide by 2. Okay, so actually that's only 2 diagonals there. Okay, for the square, there are only 2 diagonals. For the n polygon, for the when k equals 12, 12 guns, okay, there are 12 sides.
So 12.
Yeah, so the answer will be the number of, yeah, so the number of the diagonals will be 12 minus 3 times 12 divided by 2. Okay, so let's simplify it. It's going to be 9 times 12 divided by 2. So 9 times 6. Okay.
54.
Hmm?
54.
54. Okay. So 54 is going to be,
The answer.
yeah. 54 is going to be the answer. Okay. So 54 is good. So n. So you find m and add them together, you get, you know, okay. You get the answer. Okay. So n plus m. So we find n and m. So this problem will use the formula how many diagonals you're going to get. Okay. If it's an n polygon. Okay. So I don't remember the formula, but I can derive the formula. That's really important. So you can't have to find the formula.
How about let us do another one?
Okay. Okay. So my question here is, okay, yeah, what is interior angle of a regular 12-gun?
What?
Yeah, regular means all the sides equal, so all the interior angles the same.
12 gun?
Yeah, 12-gun, 12 sides.
Wasn't that the same thing?
Hmm?
The other one.
Could you do that? Right. So 12-gun, right? Each angle is the same. So we don't know, right? The sum of the interior angles, that's my hint. Okay.
Those three.
Three, 6. That's the first thing I heard.
Okay, the sum of all the interior angles, okay, is going to be, because you assume it has n, n sides, right? So it's going to, that's 12, so 12 times alpha. The sum of all the interior angle. But on the other hand, this can be 12 minus 2 multiplied by 100 degrees. Okay? So once you get this, then you solve for n. Okay? So alpha is going to be 10 times 180 degrees, thereby 12. Let's simplify it. Okay? So 12 is 2 times 6. Okay? So this is going to be 5, and this 18 it's a 3. Okay? So 150 degrees is going to be the interior angle. Okay? After you simplify. All right, my next question is, what is the parameter of a regular hexagon whose longest diagonal has length of 8 units? What is the parameter of a regular hexagon whose longest diagonal has a length 8 units? Okay. Okay, please focus on this problem. I want you to do it by yourself. This is not a difficult problem. Draw the picture, okay, and then draw the picture and then figure it out. Okay, don't talk about anything else mathematics. Okay, Joshua. What is the parameter of a regular hexagon whose longest diagonal has length of 8 units? Okay, so do you understand the question? So this is a hexagon. Okay, so this is going to be 8 units. Okay, what is a quick way to do that? I'm waiting for. Come on, Vincent. This is a regular hexagon, right? And you know the length of diagonal. Can you figure it out? Hexagon is special, right? So can you figure out the parameter? the edge length of the one side, at least, right?
Isn't this like one of the questions in the paper?
Kevin says 24. Any different opinion? Joshua?
I'm working on it.
Jonathan? They all begin with J. I'm trying to find the homework. Toby is asking me about how many possible combinations of the coins, right? I just forgot the exact thing.
Oh, that one?
Yeah.
The question was, how do you get
Yeah. Joshua, you remember the problem?
with 45 cents or 40 cents? How do you get 45 cents with
From?
how do you get
From
45 cents
nickels.
with nickels, dimes, and quarters?
I thought it's nickel time.
How many possible ways, right?
Yeah.
You can have enough diamonds, coins that matter, right? This question, how many? Yeah, that's a good question. Yes.
Looks like this.
Okay. So let's finish this problem. Okay, we finish this geometry problem, and
48.
okay. So
48.
Was it
hexagon is so special. Regular hexagon consists of 6 isosceles, 6 equilateral triangle. So immediately you can figure out the edge length is 4. Then you have a total how many sides there, right? So the parameter is going to be 6 times 8, 6 times 4, which is 24. Then
made up to 4 triangles and 2 rectangles? Or
I'm
2
stupid.
squares?
I got 6 times.
Hmm?
I got 48.
Oh.
Okay.
What time?
7 times 1.
So our next problem is the ratio of the measures of the angles of some triangle is 1 to 3 to 5. What is the degree measure of the largest angle? Okay, this is just a proportional problem, but use one formula from triangles. Yeah, the ratio of the angles is 1 to 3 to 5. Okay.
Until 3 to 5.
Oh, 100? Yeah. You see, you have 3 triangles, right? 3 angles in the triangle. Alpha, beta, gamma. Alpha to beta to gamma is 1 to 3 to 5. So this is a ratio problem, but we have to use one simple formula, right? The sum of them must be 100 degrees. So you can express alpha to be t, beta to be 3t, gamma to be 5t. So add them together, it's going to be 9t, which is 100 degrees. So t is going to be 20 degrees. Okay, then the largest one is gamma is going to be 5t, 5 times 20 degree, 100 degree. Okay, so this should be the correct way to do the problem.
Dun, 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 dun. Favorite car.
All right.
Favorite car.
So our next problem is about circles with radius of 2 and 14 units. So this is r equals 2. They are concentric. Okay, another one, capital I is going 14 centimeters, little I is 2 centimeters. Okay, so if you want to construct a third circle with the same center that will divide the shadow region into equal parts, what does that radius should be? Okay, so so this is let me put color here.
The one thing.
Yeah. What I'm going to do is I'm going to draw another circle
Middle.
in the middle, the radius called rho. Okay. So I hope this can divide, the circle divide the shadow region into 2 equal parts. Okay. Find the radius rho such that the circle with the radius rho divide the shadow region equally. Okay.
What are you supposed to do? 2 inches.
Okay, let's focus on this problem, Alex. Yeah. So capitalize 14, that I know, then you cut that, right? Then you get that shared region, right? And then you want to draw another circle which can divide the area equally. It's and what is the radius of that circle? Okay, cannot be half of the, the average value of 14 and 2. Everybody says 7. Sophia 7. Emma says 7. James says 7. 7 may be right. Joshua?
Yes.
What's the answer?
Six. I don't know.
All right, so just do the calculation. Come on, right? So the area of the interior part, right? This is the interior part, right? Is going to be pi rho square minus pi 2 square, right? And that should be equal to the area of the other side, right? So be pi 14 square minus pi rho square. Got it? So now you get an equation in rho. So what you get is pi should be gone. So rho square minus 2 square equals 14 square equals rho square. Okay. Yeah, that's what, the difference. We're calculating the area of the all sides of the circle with radius rho, right? Which should be pi 14 square minus pi rho square. Just take the difference. Okay. So now you have 2 rho square equals 14 square plus 2 square. right? Then divide by 2. So I'm not sure this is going to be, I don't know how to get 7, right? You guys said 7, okay? But my calculation tells me it's not 7, okay? So I can take a 2 out. It'll be 7 squared plus 1, right? Right? Yeah, 7 squared plus 1 squared. So that'll be 2 squared times 50. Okay. So 50. So rho squared equal 2 squared times 25. 25 is 5 squared. So it's 10 squared. So rho should be equal to 10. Aha, I'm right, you guys. So many students gave me 7.
What if the students are right in here?
Yeah, it's possible. Yeah, sometimes Joshua
That's
said,
a
well,
hard chance.
well, that's possible because I don't know how they get. You guys did not do computation probably. Just you know,
course
computation. Yeah. Just the see the area is different from the length. Okay. So you really need to write down the details, and then you calculate the area for the interior side and calculate the outside. Okay, of the circle.
A bunch of stuff.
Then you solve the equation. Okay. It don't, you know, it's not like I don't know how to get 7. 14 divided by 2. Nothing to do with the 2 here, right? 14 divided by 2 is radius divided by 2. I think this is a good question. Can easily force somebody. Okay. Yeah. So if you're not sure, just do the, just do it by hands, okay? Write down details.
What if you don't?
Or do it again.
Hmm?
Or do it again.
You want to do it again? And it's a
Yeah.
problem? No. I'm going to give you a brand new problem. Okay?
Was it close to that one?
Okay. A circle of radius 4 inscribed in a square was a second square inscribed in the circle. What is the absolute difference in square feet between the areas of the two squares? Okay, let me draw the picture. Here's a square. Okay, then you draw the circle. Okay, then another square there. Oh, I did not draw the square. You know, not necessarily parallel to. Okay, so the radius of the circle
We're trying to find the radius of the square.
is I equal to 4 feet. Okay. My question is, what is the absolute difference? Means you don't need to worry about sign between the two areas of the squares.
Well, the area of the bigger square is 64.
Okay. Okay, I'm waiting for answers. Okay, so clearly, see, a square is inscribed circle, the circle inscribed in another square, and then I know the radius of the square, radius of the circle.
I'm trying to find it. area of the circle.
And the area, the ratio, the difference between the area of the two squares. Isn't it weird that I got a larger area for the smaller square than the larger square?
Yes, it is. It's funny. It's kind of funny. Wait, how did she get a larger area on the smaller square than the larger square? Eight equals 16. 64. Equals the small square is 16. Oh,
Joshua, do you have answer?
No.
have it.
Alex says 32. 32, 32, so everybody got 32.
Well, that's 64.
Let's see. First of all, let's figure it out. You have to figure out the length, side length of each, right? Okay. If this is the one outside one called x, the inside one called y. Okay. Let's figure out what is x, what is y, right? And clearly, okay, the y. Look at that, right? So this is the radius r, right? So if you know the radius r, then you can get a y, right? So I just need to know y squared. I don't need to know the exact value y. So y squared plus y squared equals 2r squared, right? Yeah, use a perfect theorem. So that's going to be 8 squared, right? So y squared equals 8 squared divided by 2, right? And that's going to be 32. Okay, so this is a all right. So now you have to find out x, but the x is clearly x is going to be, look at the x is twice of the radius, right? Yeah, x is twice the radius, which is 8. Okay, yeah, 8. So the difference is x squared minus y squared, 8 squared minus or y squared. Y squared is 32. So again, it's going to be 32. Okay, 32 is answer. Okay, so just calculate. Yeah, y squared is 32. All right, so let's look at the next problem, trapezoid problem. The trapezoid ABCD has a parallel basis AB and BC. Okay. Okay. The area of the triangle ABD. Okay. So the area of the triangle ABD is going to be 6 units squared. The area of the triangle ACD is going to be 9 units square units. Okay, ACD. Okay. So what is the area of the trapezoid?
A, B, B, A, C, D.
Yeah. Yeah, you get the AB. Yeah, this is the trapezoid, right? And the ACD, it's overlap. It's harder to draw it. It's going to be like that. Okay. All right. So the area of these two triangles. Can you do that? It's a little bit tricky here, this problem. Right? You're not, you see how to find the area of trapezoid, right? The base, upper base plus the bottom base and plus the height, divided by 2. But that formula is not helpful at all. All right? But if you realize that this can be separate, A times H plus half of B times H, right? Then A times H divided by 2 is the area of this triangle, which is 6. And the B times H divided by 2 is the area of 9. Area of the triangle ACD. So the answer is this. Okay, just add them together. Because the triangle, here's a point. Yeah, the key point is the area of the triangle ACD is going to be the area of the triangle BCD. Okay, so BCD is the other side, so you can put together BCD and ABD put together to form it's a trapezoid. Okay, so just add them together, you get total area. All right. All right, so let's look at the next problem. Equal triangle overlays square. Okay, this is an equal triangle. Okay. E, D, F. Okay. So triangle EDF is an equilateral triangle. Okay. And ABCD is a square. Okay, here's a square. This is let's draw the square. Looks like that. Okay, I did not draw perfect. Okay, so A, B, C, D. Okay, so B is the middle point. Of EF. So what is the ratio of the area of the square ABCD to the area of the triangle? Okay, find the ratio of the square A, B, C, D, and the area of the equal triangle, and D, E, F. Okay, so the exact size is not given, but they're changing proportionally. So please spend a minute to work on that. Any ideas?
No.
No? All right, you just named the Grant said no.
Physically impossible.
All right, you don't know exact size of the equilateral triangle, but that's okay. You can let the one side to be A, but you can calculate the, you know, this side is A, right? Let's assume that the edge length of the square is A. Then you can calculate the edge length of equilateral triangle, right? Then you calculate the b's, right? So this side is a B, okay? So the ratio is going to be A squared. B is going to be square root of 3 over 4 times B squared, okay? If you know the edge length, so all you have to do is find the relationship between A and B. Okay, can you find the relationship between A and B? You know the formula for the area of the equilateral triangle, so you know the edge length, right? Okay. How do you find it? I think you needed to look at this side. Okay, let's call the H. That's our middleman. So this H. Okay, why is middleman? You have a relation between A and H. Okay, relationship H squared equals A squared plus A squared equals 2A squared. So H is our middleman. Okay, then what is the relationship between H and B? Well, H over B is going to be H is going to be square root of 3 over 2 times B. Okay, that's a special triangle. Okay, so in other words, this is this H is going to be square root of 2 times A, right? So H is square root of 2 times A, H is a square root of 3 over 2 times B. Then you find the relationship. Okay, so you can, if you just want to find A square over B square, then it's also, yeah, maybe you don't need a, don't need the H, you just need the H square. Yeah, let's just find the H square. If it's use H square, this get H square equals 3 over 4 B square. So we can have the relationship between A square and B square. This is H square, that's middleman. It's 2A square. So clearly A square is going to be, A square over B square is going to be 3 over 4. It's 3 over 8. Okay? So that's the relationship. Then you put into the above formula, then you get a solution. Okay? You put that, then the ratio is going to be, so the ratio is going to be A square over square root of 3 over 4 B square, and that can be between A square over B square is 3 over 8. Okay, so we simplified. 4 over 8 is 2. 3 over square root 3 is square root 3. Okay, so this is already the this is direct way to solve the problem. Right. Okay, our next question is, I know if the measure of each of 4 interior angles of a pentagon is 100 degrees. What is the degree measure of the 5th angle? Okay. All right. So this is not a right pentagon, just a pentagon, 5 side. Can you do that? All you have to do is just area is the sum of the interior angle, the formula. The sum of interior angles is going to be 400, you know, they're all this 4 is 100, so 100 times 4. Plus this unknown number, alpha, is going to be n 5 minus 2 times 100 degrees. Okay? So it's going to be 3 times 100 degrees, which is going to be, and here's the alpha is going to be 3 times 100 degrees minus 400. Okay? So yeah, some of you already got the answer. Okay. Yeah. So my next question is, it's a similar problem. Okay. This is from homework maybe. We have quarters, diamonds, dimes, and nickels. Okay. How many combinations together? 45? Yeah, 45. Okay. So how many
That one was 7 or 8.
combinations to give us total value 45 cents?
16.
7 or 8.
Okay. So the idea is that, okay, the number of the quarters will be Q. Q will be 25 cents. And then dimes is 10D. And nickels will be 5N. Okay? That's supposed to be 45. So this is just only one single equation. You have so many, 3 unknowns. But 3 unknowns, they're all integers. Okay? So what you can do is, the possible combination is, you begin with a Q, okay? If Q, how many choices for Q? Q has only 3 choices. Q has 0, no quarters, okay? If it's no quarters, 10d plus 5n equals 45, then you don't have many choices because d is going to be 45 minus 5n divided by 10. So then could be 1, right? When n is 1, then you get 40, you know. So, but the n can be, if n is 2 is impossible, n must be 3, okay? N must be 5, n must be 7, okay? And n must be 9. So when n is 9, then that's this many choices, right? Then it's divided by 10. Otherwise, it's not, right? So you only have those so many choices. You can find the d's of a d value, blah, 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 right? If n is determined. So the second one, q equals 1. If q equals 1, this way, how do we count them, okay? This is when q equals 1, you know, when q equals 1, then you have a 10d plus 5n equals, okay, only 20. Because 45 minus 20, 5 is going, 20. Then not many choices. D equals, d equals 20 minus 5n divided by 10. But then n can be any, n still not be many choices. N can be 0, right? Right? But n could be 2, right? N can be 4. Right? Yes. Then you get all the solution. Then third case is q equals 2. When q equals 2, no, it's impossible. Q equals 2 to be 50. So then you stop there. That's it. And you get all of them, right? So you have how many total, right? You have 3 at the bottom. You have the only 2 groups here, right? So 5 plus 3 total 8. That's 8 solutions. The 8 combinations. All right. So yeah, it's hard to solve them directly, right? The 3 variables there. But first of all, they're integers. The integers means that only find many solutions. So you just let one of the variable to be 0, 1, 2, 4, that. Then you simplify the equation in each category. And then the reason I choose Q is because that if Q is 25 times Q is a very large number. So there are only 2 choices for Q. Q equals 0, Q equals 1. Then I can only 2 type of equations I need to deal with. Otherwise, if I choose N, then I have so many choices for N. Okay? Then I have many equations. Although each equation solutions are very few, but that's more complicated. So this is an experience. So you need experience when you do, so more exercise you do, then more experience you can get. So that's why I choose Q to classify into 2 different equations. Okay. So today we stop here. I apologize the inconvenience because my laptop I cannot start it.